Hi, this is Jim Montague, Executive Editor of Control Magazine and ControlGlobal.com, and this is the fifth in our new Control Amplified podcast series. In these recordings, we're talking with expert sources about important topics in the process control and automation field and trying to get beyond our print and online coverage to explore some of the underlying issues affecting users, system integrators, suppliers, and other people and organizations in these industries. For our fifth podcast, we're talking to Sam Russem, Director of the Smart Manufacturing Practice at Grantek Systems Integration, a system integrator with offices throughout the U.S. and Canada and a certified member of the Control System Integrators Association. Sam provided some excellent input for our two upcoming stories on historians and data analytics, and I thought this might translate well from our usual print and online venues into this audio format. Oh, and since we're covering two stories and two topics, I'm attempting to do two podcasts about them, so this will be part two. I think I can justify this plan because conducting multiple interviews for a print story is what eventually gives it real depth. I'm pretty sure that will be the case here as well. Okay, Sam, sorry for the long preamble, and thanks for joining us today.
Yeah, thank you, Jim. I'm really happy to be here, and I think it's great that Control is doing these podcast series. I definitely have a lot of coworkers and people I work with that have been looking for something in this space, so I'm happy that you're doing it and that I get to contribute.
Okay. All right, let's get started then. First off, if historians have evolved to the point that any device with a microprocessor and software can be set to collect and store long-term data, then what the heck characterizes a historian, quote unquote, these days?
Yeah, so good question, Jim. I would really say that the core definition of what makes a historian really hasn't changed. It's more the platforms that can host that historian and the versatility of options that opens up when you can put them in more flexible places. So let's start with that main definition, right? So that core definition of what a historian is generally it is concerned with the efficient collection and storage of time series data, right? So really the difference between what I would call like a real historian versus like a data logger is the speed and the scale of it. So a historian is going to be able to read manufacturing data at very high rates, usually a second or faster. It can certainly go longer, but it needs to be able to do that high-speed recording. And then it usually uses some types of compression algorithms on the back end to efficiently store that data for the long term. One of the other main features of a historian that we're looking for is the ability to store and forward information too, right? So it's great. This means you can have a local historian on a machine or on a line that is responsible for that high-paced local logging. And then it usually is going to send that to maybe a higher level, enterprise level historian for longer term storage. Now where the store and forward piece of that comes in is accommodating for the situations where the local data logger and your enterprise logger have become disconnected. For some reason, you still want that local historian to continue to collect data and then seamlessly synchronize that back up to the master historian once that connection's reestablished. So really what I'm talking about is you're asking around microprocessors and kind of being able to put a historian in more places. Those core features are the same, but absolutely as we've increased our compute power and our storage capacity, the footprint required for a historian is a lot smaller than it used to be, so you could put them in various places in your system architecture as opposed to one big single site server.
Okay, so they're kind of more function-based than, a particular hardware type item. Is that the mental shift people have to make, do you think?
Yeah, definitely. If you're thinking of a historian as a single-use piece of hardware that puts in, it's definitely a more flexible piece of software than that. So it's really a matter of, that core function is the same. If you need to be collecting data and storing that for a very long time at a very fast rate, historian is your tool to do so, but there's a lot of flexibility that you have in terms of analytics or machine learning or even just basic trending in the way that you apply that tool to get the result you're looking for.
Okay. So then given how much the historians have changed and become more software, less hardware, what kinds of new ways and places are they being applied, maybe where they couldn't be used before, and how is Grantek carrying that out?
Yeah, sure. So let's take a look at some of the features I had mentioned earlier, and kind of I can bring a certain example of those around. So we talked about the store and forward, we talked about the local logging, and we talked about that price point coming down so you can put it in different spots in your architecture. So one really cool use case that we were very happy to work on over at Grantek was for one of our customers that owned a number of renewable energy assets, and they had a problem around being able to collect and store and do analytics on data from a bunch of their solar power sites across the U.S. So definitely an issue where their main center for actually using that data was in a centralized location, but the actual sites they needed to collect that data from were across the country. So at a high level, what the solution architecture there looked like is that Grantek was installing PLCs with historians in the chassis at each of these sites. So that PLC was still responsible as your main data concentrator. It could speak a lot of different protocols. That versatility was really important so that we could standardize on the historian hardware regardless of what other hardware was installed at a particular site. It also facilitated some controls and some HMI screens and things like that. But one of the main things that this included was a in-chassis historian that would do all of the monitoring for the important historical data. It could record all this, and it would send it to their centralized historian instance for more detailed analytics and reporting. One of the most important features in this architecture was around that store and forward capability. So solar sites are built all over the country, and not all of them always have the greatest and most reliable internet connections. But losing data could really provide major problems with your analysis, or even some regulatory issues if you weren't able to show some of your generation metrics, right? So the ability for that historian on site to run for as much as 2 weeks or longer without necessarily being able to report back to the mothership, and once it did have that connection reestablished, that all the data would just flow like nothing had ever happened, was a real big selling point for that, and helps to solve a lot of problems with that particular instance. One of the reasons I bring this up is we would want to compare that to the counterpoint, right? So let's say that we didn't have these cheap historians that you could put all over the place and easily implement an architecture like that. A couple years ago, if you wanted to do something similar, you're talking about putting a historian server at every site. So a Windows-based server usually that runs that communication software and runs your historian and stores a lot of that data locally. That's a pretty powerful set of hardware for a solar site that is generally something that's not enough of a revenue-generating asset to always justify that type of an investment. So really what this has done is for especially sites like this where you do need to have a record of that data, it means the entire footprint of a solar site could be smaller than it just was, because your initial hardware investment isn't quite what it would need to be if you did need to throw a full-blown historian into each one of these sites.
All right. So then, once all the data is gathered and stored, and since the only thing that changes faster than hardware is software, how are data analytics and those tools and technologies changing lately? I mean, I assume everything's in the cloud, but what happens once everything gets there?
So let's say you start with your thing about the cloud. So as far as all the data is going into the cloud, I would say that's in one way, shape, or form usually, but not all the time. And actually, we like to think of the cloud as kind of three maybe separate ways of approaching it sometimes. So there's kind of the big cloud and the big data analytics piece of things, but there's also enterprise or local level clouds, and then sometimes there's really justification to not put this data into a cloud at all. So let's break those down a little more. If I talk about those big data clouds, that's where you don't own your servers at all. You've completely offloaded most of that compute power to a Microsoft or an Amazon or something like that, and they have a lot of the responsibility for the maintenance of those servers and their uptime. So not everyone, I think, is quite comfortable with that idea yet. We do still hear about things like data breaches and security concerns all the time, and we're talking about some proprietary and potentially sensitive data that we could be storing in these systems too. So I'm not trying to scare you away from using those distributed cloud architectures with a solid design and security in mind. That type of planning can go a long way to really mitigate a lot of those risks, but the hesitation is certainly there, and I think that there is some understanding that maybe not everyone's ready for that just yet. However, most manufacturers are going to have some type of local or on-premise cloud or a cloud within their enterprise. So if you're still using locally hosted SharePoint sites, or if you do have a situation where you're taking data from individual plants and sending that to a larger enterprise instance for analysis, that is more of a local on-premise cloud, and I think a lot of the technologies and advantages that come with cloud can still be realized in that type of model. But we also do need to have solutions for people that aren't ready for a cloud yet. Maybe their data is very, very sensitive and there are security reasons that it really can't go outside of a site. Or sometimes there's just other infrastructure or pieces of software that aren't quite ready for that yet too. So how do we bring the analytics into those types of situations as well is always an interesting question.
Well, I was kind of wondering, and this is a bit of a backpedal that I apologize for, but
That's okay.
if I've got a series of historians, how would they get their data to a local or enterprise cloud server? How would they do that, and what kind of networking might be involved?
Yeah, good question. So designing one of those things with security in mind and kind of putting the right data at the right level for the right users is always a challenge and a discussion that needs to be had, but there's definitely a lot of standards out there for ways that you can do that in a secure and efficient way. So a lot of times, for example, you'll have a lot of your data at a plant level. So I'm going to go with a model where you have multiple plants that you want to connect to an enterprise level server, right? So some of the most commonly accepted design criteria for doing that would be to have your machine network within a plant kind of have free exchange of data. Certainly you're going to have some VLANs and some segregation in that, but kind of if it's within the four walls of the plant, any data that's collected is fair game to anybody at that level, and the historians that you might have on individual lines or a single one for the plants is all free to exchange information. But when you're talking about getting things then out of the plant and into an enterprise level, then you're usually connecting to more business networks. At some point, you're going to have an internet connection in there, and then security becomes more of a thing. So one of the common ways to address that is going to be by installing some type of DMZ system that separates your critical manufacturing processes from the wider internet. And one of the things that's not uncommon to do at that level is to also abstract out some of your data. So maybe all of the information that's being collected that's relevant to a plant isn't necessarily important for what your enterprise is going to need, and sometimes the less detail that you can provide is going to give you all more security. So maybe you have an intermediate system that lives between your manufacturing network before things get to the enterprise that prunes some data and makes sure that only the things that are actually necessary and going to be used are being sent up to that level. So that's one approach that I've seen to try to take security in mind as well as some of your local requirements and making sure that you have the right data at the right level for the audience that you're trying to address. Does that answer your question?
Yeah, I think so. And one thing folks always want to know is, can this be happen via regular garden variety Ethernet, and if so, what would their regular field bus protocols or Ethernet protocols would be how this would be conveyed, right?
Mm-hmm. Yeah, good question. So a lot of the times once something has hit a historian, it should be going over Ethernet at least after that. So most of these historians and the way that they're going to talk and do that store and forward and things like that, that does need to be over some type of Ethernet or wireless or IP-based connection. If you're going below the historian level, so if I'm thinking of the ISA 95 model, I'm thinking of your historian being in a level 2 system, and if I'm going down to more of the physical devices at a level 0 or a level 1, as long as the historian can handle it and your data concentrators can, it should really not matter what the protocol is out there in the field. It could be serial connections, it could be various protocols of a Modbus or a field bus. Then it's going to eventually consolidate all that data. It's going to get it into your historian. And then, yeah, I would generally recommend that as data is coming out of the historian up to higher levels, be that consolidation into a larger historian or providing information into your SCADA, your analytics system, that's mostly going to be happening over Ethernet or wireless.
Right. Okay. So just, as the historians have multiplied their abilities and places where they can be deployed, what are some of the new ways that, data analytics are being used that maybe are untraditional or didn't happen maybe because they were too costly or difficult in the past?
Sure. So I kind of have two approaches to that. One is more kind of around people, and the other is more around some of the process. So for the people part of it, a lot of us, when we're thinking about analytics and cloud and things like that, we're thinking about kind of that big cloud data lakes and big data analytics and an easy button where I just send all of my data off to AWS and they come back to me with curated insights on how to improve my plant and my process. We see advertisements for that within a football game, right? So that's absolutely something that's available and out there, but I don't think it's always accessible to everybody or realistic for where the rest of their operations are at. That's not the only way that you can get analytics, though. You don't need to have very high-value data scientists or abstracted machine learning algorithms all the time. Sometimes it's good to just give a higher capacity set of tool set to some of your high-capacity workers and see what they can do with it. So there's more. One of the things that we've seen is more analytics products on the market that are targeted towards giving your people a better set of tools to do the work with. And there's a lot of advantages to that. So sure, it is great to have data scientists abstract a lot of the information and look at it that way, but you can also get a lot of benefit from having somebody that really knows your plants and knows your process and knows those machines to give them a more powerful tool than just Microsoft Excel to go ahead and start to figure out some of the underlying patterns in your data. So sometimes the biggest bang for your buck is actually going to be giving those tools to high-capacity people, putting in a little bit of training, and seeing what types of responses and analytics they can come up with.
Is there an example of, if I was searching for a tool, a tool to empower my high-capacity worker, what would I search for, or is there packages that are typical and could be mentioned?
Yeah, so there's a lot of software in the market that does it. Certainly you would be looking for analytics tools. You would be looking for something that has probably an on-premise option that is going to that's going to imply that you don't need to necessarily be sending all of your data off-site, and that if it is on-premise, then, or at least has an on-premise option, that's going to imply that it's going to give you the tools to do this without necessarily sending it off-site. There are a couple of technology partners that we are hoping to have some announcements around very soon that hopefully would even be ready before this podcast to be released, around some of the partners that we've found that are very strong in that space, because that's where we've seen a lot of success with our customers.
Cool. All right. So are there, any experiences or best practices to share about applying historians or data analytics that the listeners can perhaps use in their processes and facilities?
Yeah, for sure. So this is definitely a question we get asked a lot, and I have two answers that I'd like to give for this one too. So the first one is to make sure that you are applying, understanding that these are tools that you're applying and not just out-of-the-box solutions. So you need to make sure that you're applying them with a solution purpose. And the two of those kind of really go together hand in hand. So a lot of people come to us and they're very excited. They've come with a new piece of equipment and a new tool in the historian analytics space that they're very excited to implement, especially because of there's a visual appeal to a lot of this, right? There's always those nice looking screens and nice looking graphs, and that there's that excitement to say, yeah, I want all those things. And that excitement's great. I certainly don't want to temper that at all. But you need to make sure that you do have all of this tied to a business case and an idea of how you're going to use it to improve. So really what's another way to kind of put it is of all the 5 W's and the H and all that of questions, you have your what. You have your historian analytics. You have the thing that you need to do something. But you need to make sure you understand the why of what you're going to try to get by implementing those tools, which is going to figure out how you're going to bridge the gap between the two. So and for a very high-level example, you've bought a Historian Analytics engine, you'd plan on putting them out there, this is great, but I would say make sure that you have a goal like, I want to increase the throughput on the bottleneck machine of line 1 by 3%. And by doing that, if I can improve that efficiency by 3%, it's going to equate to X dollars of added productivity. So if you come into it with a goal like that in mind, that's going to change the data that you start to collect. It's going to change the analytics that you actually run. It's going to change the follow-up products that you drive from the initiative as a whole. And it gives you a clear ROI beyond just the tool itself to say, if I am able to accomplish this goal of a 3% savings, this is the amount of dollars that I've used to justify my investment in this solution. So the other part of that goes hand in hand is to make sure that you plan to have follow-up projects on these initiatives. So following that example of putting an analytics and historian system onto your bottleneck machine, it's going to come up with a lot of different and interesting insights for you around maybe your top priority faults, or potentially ways that you can be tweaking parameters in that machine to improve throughput. But a lot of these solutions don't end at you doing the analytics, and there are follow-up projects that you need to do. If you are going to be applying machine learning or individual tweaks to machine parameters to see if you can increase efficiency, there's a lot of effort involved in that. It should be still done in a controlled, project-oriented way, just like you would if you needed to, say, write up a project to try to reduce occurrences of the most common faults on it. So the message being that just to remember that these historian and analytics platforms are tools for you to become more enabled as we do follow-up projects and become more strategic in the way that we target the projects that we do to make our machines better.
Yeah. Was there any, I always ask people, was there any particular headaches, about getting, in this case, historians and data analytics of a modern nature, implemented, or was there any pleasant surprises that you guys have been through recently?
So I will say that one of the most common headaches that we run into around historians that have been installed for some time is a lack of confidence in the data that goes into them or comes out of them. And I think that that's a really good lesson learned for both coming into existing historian installations or new ones, is making sure that the validity of the data that goes in and comes out of those is accepted and something that can be proven. So I can't even count the number of times that we've come in to look at an OEE system or some type of historian and analytics system where the goal is to rip and replace everything that's there because people have lost faith in the data that they actually see out of these solutions. And that's a hard thing to rip and replace, at least cheaply, because the entire question is around the underlying data, and to go through and to figure that out and to validate all that again is the majority of the effort involved. So that's definitely one. And one of the ways that you try to avoid that is through proper system validation and through proper maintenance of the system and maintaining that documentation as well. So you should really have a good idea of the data that comes into the system and how it got there and how it's calculated. So if there is a breakdown at one point in the integrity of that data, that you have a checklist of places to look to try to center in on the problem. If you don't have that in the beginning, it's just going to become larger and larger over time, and hopefully you want to catch it before you run into a rip and replace situation.
Yeah. Well, it's encouraging. I mean, reintroduce yourself to your existing application and processes. That's good advice.
Yeah.
Finally, I hesitate to ask because I'm, uncertain about what comes next as usual. But, how do you think the historians and data analytics are going to likely to continue evolving in the future?
Yeah. It is an interesting thing to think about for sure. I would say that one thing is that I do think that we're not done with the trends that we're seeing in terms of the footprint required for a historian becoming smaller. I do think that the compute power required, the price point of that compute power and the price point of the storage is going to continue to make these more commonplace and be even more flexible in where you can put them. So we've seen, again, where one day it always had to be a dedicated server historian system, and then we evolved to the point where maybe it's something that can go into a PLC chassis. We're seeing evolutions now where that idea of having a dedicated card in a PLC chassis is going away, and the intelligent PLC runs the historian itself, where you have a dedicated IoT device that's at a very low cost that could also act as a historian. I do think that trend is going to continue, and the flexibility in where we can put these historians is going to continue to increase. Another one of those, I would say, is actually, and a trend that we've already started seeing, is OEMs starting to proactively adopt some of these solutions to add value to the machinery that they're selling. So if I'm an OEM and I make a case packer, one of the ways that I can differentiate myself from my competition beyond the areas that we've competed on in the past, like ease of integration or actual throughput of the machine, is having it ready to go with smart analytics for the future. If I can sell that case packer that has a historian and insights on how to continue to improve the machine and better integrate it with your other pieces of software, that's a real competitive advantage that I think not everyone is necessarily competing on today, and I think it's going to really get ahead of the curve. Then maybe one of the other more out there ideas that we've definitely heard some rumblings around is things like shared insights. So it's going to happen, I think, over the long term, certainly as the diminishing returns from these types of on-premise data happens over the next 5-10 years. The question becomes, do we hit an inflection point where the amount of data that you can analyze, that you can provide yourself from your plant and your enterprise, isn't enough to get value-driven insights anymore, and you might need to pool with your competition, frankly. One example I've heard is around filling machines for beverage manufacturing bottling systems, where, again, we can continue to run analytics based on the information we have from a line or from a plant or from an enterprise, but maybe one day in the future it's going to make sense for a consortium of beverage manufacturers with similar bottle fillers to pool all of their data together and get shared insights out of that drive value across that whole industry. We might get to a point where a lot of the individual levels of data we get are no longer sufficient, and that's where we need to go for our future insights, and that'll be a really interesting day.
Yeah, it sounds like we're going to have to do more podcasts going forward on this topic then.
This has been fun. I'm happy to do it anytime.
Oh, man. Well, there's often these stories that we do are just snapshots, and things will evolve, and then 6 months or a year or two go by, and it's like we need to check back in on, these things that may have, other wrinkles that may have come up. All right.
Yeah. Send this back to me in 5 years, and I'll laugh about all the silly things I said.
I will. I was so right, or oh no, it didn't work out that way. But we'll I don't think we're going to keep score. And listen, those were really some enlightening thoughts. In my case, I'm progressively less confused about historians and data analytics, and more able to tackle my upcoming stories. Thanks again for talking to us today.
Yeah, of course. Thanks again for having me, Jim, and I hope we get to do it again soon.
Okay. All right. This has been another Control Amplified podcast. I'm Jim Montague. Thanks for listening. And please remember that Control Amplified podcasts are available on most podcasting apps, such as the iTunes Store and Google Play, and on Control Magazine's YouTube channel. Plus, I think you can also listen at controlglobal.com, of course. Thank you.